Hello everyone. In this video, I'm going to go through a demo problem. So please make sure to download the template notebook file for Monday's lecture to follow along. You can go to the course website and find function references entry. Once you click on the code link, you should be able to download the template notebook file. I've already downloaded the template notebook file here. We just went through example number 1 using PyTutor. So let's move on to example number 2 here. Example number 2 is going to enable us to apply various transformations to all items which are contained within a list. I have an example list here which contains 3 items which are all string values. We are going to write a function called apply to each, which is going to enable us to apply the int function to each item in this list L over here. I've provided to you the detailed pseudocode for the apply to each function. Let's quickly go through the provided pseudocode here. Whenever you're writing a function, the first thing that you need to always worry about is what sort of input does the function take and what sort of output does the function provide. The input to the apply to each function is going to be 2 values here. The first one is going to be the list object reference and the second one is going to be the function object reference here. So we are going to take this function object reference and apply that transformation function to each item which is contained within this list. So the output is going to be a new list which contains all the transformed objects. Let's start writing this function. So I'm going to say def apply to each. I'm going to have 2 parameters. The first parameter I'm going to call it as original underscore L and the second parameter I'm just going to call it as F. So first step in the pseudocode here says initialize a new empty list for output. So let me go ahead and call that as new vals and I'm going to initialize that to a new list. For now I'm just going to print the original list as such and let me run this particular function definition. Let's call the function over here. We are trying to apply the int function to the list L using apply to each function. So we have to call apply to each function and pass L as the first argument and the second argument should be the int function, right? Let's go ahead and run this particular. Give me just 1 second. Alright, there we go. Looks like I did not run the previous cell correctly. We are getting a display which shows the original list. That's exactly what we are doing right now. Step number 2 says process each item in input list. How can you do that? Recall that you can iterate over a list by saying for val in original underscore list. What exactly this for loop does here is that it will take each item in the list here and put it into a variable called val. So now if I go ahead and print val, that's just going to display each of those values in each line. Recall that if you use the range built-in function here, you're going to iterate over the indices rather than iterate over the values. So make sure to understand the difference between these two kind of for loops. A lot of students are still having issues trying to understand the difference between this for loop and the index based for loop. So let me give you an example of the index based for loop here. So I would say for index in range of len of original underscore L to iterate over each index in the original list. And now if I print index, that's just going to print the index of each value. So if I want the value, I'll have to say original underscore L of index. We need to index into the original list to get the value. Hopefully this difference makes sense to you. If not, please make sure to go back and review that particular concept. Alright, we have done step number 2. We at least know how to go over each item in the input list. What is step number 3? apply the function passed as argument to the second parameter. Since f is a function object reference, you can simply call f by saying f of something, and what's going to be the something? That's going to be val over here. So let me go ahead and run this particular version of the function. So nothing is going to come as output because I removed the print function call. Let me fix that. You're not going to be able to see the difference between the previous version and current version because print formats both integer and string to appear like the same set of characters onto the screen. So let's go ahead and move on to the next step here, which says add the transformed item into the output list. How can you do that? New underscore vals is a list. So you can simply say new underscore vals dot append of f of val. What is step number 5? It says return the output list. I'm still seeing that a lot of students are having trouble understanding where exactly to put the return statement. A lot of you are trying to add a return statement into your for loop for whatever problem you're trying to write the code for. That doesn't really make any sense, right? Your for loop is supposed to iterate over every item in your list or every item in your data set or dictionary, whatever you're iterating over. So unless you really want to be done with the entire function after iterating over the first value itself, then this particular return statement is incorrect, right? Because the minute you run your for loop, you're going to return from inside your function. So if you want to do something with just the first value of your list or whatever data structure you are iterating over, you don't really have to write an iteration for that, right? You can just apply that by using indexing or key lookup if you're using a dictionary. So typically when you write a for loop, you want to be able to done with it before you move on to doing the next task. So the next task here is going to be to return the new underscore vals list. So that's going to be indented out of the for loop block. So the for loop block is going to be at the same level of indent, whereas anything that's going to have the same level of indent as the for keyword itself is going to be outside your for loop. Alright, let's go ahead and test this function. We started off with a list of strings, and after the transformation we have a list of integers over here. The next function is going to become an add-on to the function that we just wrote. We want to write a function to strip the dollar at the beginning of an input string. So input is going to be a string value and output is also going to be a string value, but we want to check whether the input begins with a dollar. If so, then we want to remove it. So let me go ahead and define the strip underscore dollar function. What is the input? The input is going to be a string. So what do we want to do with this string? We want to check whether the input string begins with a dollar or not. So recall string methods here and think about which string method will enable us to check this particular concept over here. So we want to check if s starts with a dollar. So we're going to use the starts with method call. So I'm going to say if s dot starts with, and the argument for starts with method is going to be dollar. Then we want to strip that particular dollar, correct? How do you create string transformation? Recall that you can use slicing to do that. So I'm going to simply say s should now be equal to s colon, that's going to be a copy of the string, but I want to leave out the first value, which is going to be the dollar. So I want everything after the dollar. Dollar is going to be at index position 0. So I'm going to say s of 1 colon, which is going to get me everything starting at index position 1 over here. Recall that strings are immutable, so you cannot simply make modification to the original string. So what we are doing here is when we take a slice of the original string, that creates a brand new string object in the heap memory. We are just reassigning the reference inside the variable s to the brand new string object that we just created. what do we want to do with this string? We just want to be able to return it. Right, let's go ahead and apply the strip dollar function first to this list of string values. Notice that some values contain dollar at the beginning and some of them don't. You might have written similar functions for your projects. So let me go ahead and copy this invocation of the function. Instead of applying int, I want to apply strip underscore dollar function. And I want to be able to capture the return value here, right? I'm going to say vals equal to this. Let me go ahead and display vals. Let's go ahead and run this particular function. Notice that our input contained two items which had dollar at the beginning. Now you have stripped those dollars. So this particular section is saying apply strip dollar function and then apply int function. How can you apply int function? We just saw an example for that. Instead of applying int function to the original list, which is L here, we want to be able to apply it to the new list vals. And let me go ahead and run this particular set of code. Notice that now we are finally ending up with a list of integers after stripping the dollar sign at the beginning of each of those strings. Right, let's go through one other example here. We want to apply the upper method call to the below list using apply to each function. So method calls can also be used as function object references. Just like a default function has a reference, a method call also has a reference. So I have a list of strings here. I want to be able to apply the upper method call, which is part of the string sequence, to each of these items. I can use the upper method call because each of my item is of string type. So the way that we are going to do this is I'm going to say apply to each, and I'm going to pass L as the first argument. What should go into the second argument here? So recall that when you're calling the string method call, you would say L dot upper, and that's going to just um, you can't call that on a list, so you can call it on a list entry, which is a string. Excuse me for that. So L of 0 dot upper is going to just apply the upper method call for the string AAA, correct? So how can we pass the upper method call as the function object here? Recall that there is a different way to call the string method, and you can say str.upper and you can pass L of 0 as an argument to the upper method call. Both of those do the exact same thing. So if I print the output that is coming out of both of these method calls, you'll notice that both do exactly the same thing here. So we are going to use the second method to pass the function object reference here. So I'm going to say str.upper, and that's going to make apply to each function run the str.upper method call on every item in the list L, correct? So we are now able to transform the original list to contain a list of strings where all the strings are uppercases rather than the original smaller case letters. I'm just going to briefly introduce you to a function called map. We'll be using this extensively while talking about generator functions. For now, I just want to show you how map function works. We just now wrote apply to each function, which enables us to apply a specific transformation function for every item in a list L. Map basically does the exact same thing. So you can say map of int comma L. That's simply going to apply the int function for every list item over here. The only thing is map function returns a generator object. For now, you just can use that object by typecasting that into a list over here. So if I now call list on map of int of L, that's going to typecast the generator object returned by map into a list. Notice that you're getting a list of integers. when compared to the list of strings that we originally started with. So you don't have to essentially write your own apply to each function. You're more than welcome to use the map function to do the transformation. I'll wrap up this video here, and we'll talk about one more application of function objects in the next video.